Hello, everybody. So tonight will probably be kind of a short night as it's Wednesday evening, the day before Thanksgiving. So after class tonight starts the holiday break, and I'm sure everybody is anxious for a little bit of time to rest and relax, maybe do some traveling and all that. But we got a few things to talk about. In particular, the next section is over graphical user interfaces. And on this one, it's another one of those where our acronym is at least a combination of letters that somebody looked at and thought it was seemed pronounceable. So we usually do for GUI, pronounce that like the word GUI. Which I hope you already knew that because I've been using that word regularly this semester. I already regularly use that word. Hopefully you were already well aware of that. Just a few things I want to talk about in class over it. One, I've never found a textbook that I am happy with the coverage of these. Not the textbook for this class, any textbook at any level. I don't know what it is about academia and putting together graphic user interfaces, but so many times across the board in academia, they treat the graphical user interface like a bad thing. If it was up to me, I would start showing how to make a GUI on day one of the first programming class. Because when we just talk about making software, about developing software, we're probably thinking about something that the user interacts with the GUI, not things that run in the console like we've been doing. I remember I was around for the change when we had to use everything on the computer had to be done with text in a terminal. And then one day there was a big change and we had GUIs for everything. We could click on pictures with a mouse and it automatically wrote those terminal instructions in the background for us. I'm so glad when that happened. Thought I'd never have to work with the terminal again. That wasn't the case, but the user interface is kind of a big deal when it comes to a piece of software. And I'm not very happy with the general approach of academia to it. Like I just said, I would start showing how to make a GUI on day one of first programming class if it was up to me. But unfortunately, if I did that, the people who had me for that class would not be material that aligned to any other programming class at any school anywhere. So can't really do that. And then whenever the classes generally do roll around to covering GUIs, I have never found a textbook that I'm happy with. In most textbooks, what they cover in the GUI section, I would not even count as acceptable for a dialog box. The dialog box that pops up asking you, are you sure you want to close without saving? Most of the GUI coverage in textbook, I wouldn't count even as acceptable as the message box that shows asking a user if they're sure they want to close, or asking a user if they want to save before they close the program. It's barely mentioned. It's like treated like a bad thing, but I feel like it's going to be a very important part. So we're going to talk about it a little. Our textbook gives a little bit better coverage than a lot of them I've seen. But they do this one thing that I think is really, really weird. And that really short chapter on object-oriented programming. just a very fundamental, basic first steps introducing the ideas of object-oriented programming. And then the next chapter is about GUIs, and they do everything with advanced object-oriented programming techniques, which makes it extra confusing. So also in class, we're going to be doing not object-oriented, because nothing the textbook does draws any benefit from doing it as an object-oriented thing. There's no benefit to using the classes. Benefit doesn't show up till you do something like make an office suite. Microsoft Word, Excel, and PowerPoint, and all those, and you want them to be similar, to clearly be part of the same thing. And then we make a parent GUI that the other ones will inherit from, and that way they're all part of the same office suite. So until we get up to stuff like that, there's not really an advantage to using object-oriented programming. There's a lot of extra stuff that has to be written in order to do that. We can't, if there's nothing's going to be inheriting from it and using that inheritance, there's no advantage there. And object-oriented programming is actually worse for the computer. So it's a loss of efficiency to do it if we don't get anything back from it. So for what we're going to look at in class, well, actually, I was going to look at both ways, and then most of the class examples, because we're going to talk about it more than one night. Tonight, technically finishing up our Python section, and then we're going to spend the rest of the semester looking at some other things that will be useful for you. Homework assignments on week 7 will be written depending on what we talk about. Because we can talk about different things that I think will be useful for you all, and then homework will be based on what we talk about in class. So I haven't posted the homework assignment. One for week 6 is there's other useful tools that we'll see. But in class, we're still going to talk about GUIs a lot because I think it's a big deal. So we're going to talk about these a few nights. Most of our examples will just set it up with just regular functions, like we've gotten quite a bit of practice with already. The big point that I like to make, though, has to do with, well, like I said, most textbooks, what they present as their coverage of GUIs, I wouldn't even count as acceptable for the dialog box. So there's certain things our users will expect when they go install a piece of software. And hopefully you all agree with this. I usually see lots and lots of head nods in class when I'm talking about this section, but when you go to try out something, you need to do something. So, it's not something you regularly do. You need a piece of software for it. You go to Google and find like those lists that show 5 best, 10 best, the blogs reviewing different things, and you'll try different things on that list. How much time does each particular piece of software get when you download, install it, open it up? And here's developers now, which I'll just put it in terms of time. When somebody does that, user goes, downloads your software, installs it, opens it up for the first time, you have about 5 seconds to convince them to use it. And you're not going to talk to them during that 5 seconds. They're not going to do very much. They're not going to finish a project with your piece of software in that 5 seconds. So there's a very limited number of things we can do in the 5 seconds that you're just going to spend with your software deciding whether or not to use it. And so it's one of those things that it's kind of important to follow the conventional appearance of software. That way, when somebody opens it up for the first time, they know what to do with it. Share my screen. And there are certain conventions that software follow. Open NetBeans here. That has a lot of them. This is the IDE we're using for the Java class on Tuesday and Thursday nights. So just looking at the GUI, not necessarily worried too much about what all of the software is doing, but we see something we see all the time when we open a piece of software. Up at the top, we have this main menu. some sort of icon in the corner, this main menu going across, some information in the middle. Quite often we expect to see the file name written there. Right? That's the standard place to put the file name. And right below that, we have a toolbar with a bunch of buttons, functionality that's also available in that main menu. It's just like our most popular ones get a picture and get put right there. We expect things to happen when we right click. We get a menu that gives us another way to do things. All of our main content is kind of there in the middle. And down at the bottom, we have any of these. I guess I need to open something. And then down at right click and we get a menu to see stuff. And down at the bottom, we have this status bar telling us what's happening in the software. But right now, it was updating. A second ago, it said it was updating in the background. And now it just says where the cursor's at. It's on line 10, the 16th letter on line 10. What else does it say? It's set for insert mode, and there's a carriage return line fee. Important information to pass to a programmer. But important information about what we're doing is happening down there at the bottom of the screen, filling this in. There's some other ones. Oh, I got Word here. Open Word. We have a similar thing. Oh, and one other thing on NetBeans. Y'all probably haven't used NetBeans yet. That's the official IDE for Java. There's lots and lots of different ones to use, but that's owned by, this is one made by Apache, and Apache is a subsidiary of Oracle that actually owns the Java programming language. Y'all haven't used this, but this, like a lot of software that you would look at for the first time, you know that if you come over here to the top right corner in that main menu, the very first thing is a menu called File. And if we click on that, the top option should be our new project. There's a convention for how we start whatever it is we do in a piece of software. We go over there to the File menu, and the top option should be new. And we start a new, whatever the software does. In this case, start a new Java project. Or Microsoft Word here. It's similar. They have an updated version, a slightly different version. They combined the main menu and the toolbar into one element. We call that a ribbon. But the same basic idea is there. We have that. The main menu are just tabs now. And then each of those tabs holds a separate toolbar full of buttons that carry out the functionality we need. And once again, very first time we look at this software, if we go to the top left in the main menu, there's a button that says File. And right there near the top, it's the second one here. But right near the top is a button that says New. And that's how we get started with this software. So there's sort of a convention for it. There's one other style of appearance that I want to look at. Does this have it? It doesn't collapse. I think Jamboard has it. We go to Google Jamboard. Google Keep has it. Google Keep, if you haven't used it, it's the it's like Post-it notes with check boxes and stuff, but the virtual version of little Post-it notes. I tend to use that a lot because it syncs with all the other devices, the phones, the tablets, and watches, and whatever I have on, I can open the same Post-it notes from anywhere. This one doesn't have a menu across the top, but it has this symbol that we're being kind of used to. The hamburger is what we call that. And our menu goes down the side. And when we click that hamburger, it either shows or hides our main menu with all the functionality that the software has. So quite a bit different than the others, but still sort of a convention that we follow when we do these together. And I wanted to start talking about that because it's important to follow those conventions. When you make a new piece of software and release it, you only have a few seconds to convince the users to use it. They're going to look at it for 5 seconds or so. If they can't figure out what to do, then they're probably going to go look at something else. But if you follow following those conventions, I'll just draw kind of the original style one up here. Whatever that piece of software does, if it has those conventions, like up at the top, we have that main menu. And right underneath of that, this nice little toolbar with pictures of our most common functionality or most used buttons, all of our main content. And then down at the bottom, we have some little area for a status bar, keeping the user up to date on what the software is doing at every given step along the way. Well, first time people open this piece of software, it looks like this, they already know how to use it. They know that if they come over here to the top left corner and click that button that says File, a little menu is going to drop down, and one of the options in that menu will be New. And then they can start doing work. So you have a very, very limited amount of time to convince your user to use your software. So following those conventions goes a long way in filling that time. So that was something I sent out some files just a few minutes ago right before class. So you could follow along and so you could have them as an example. And these files, I think they're in downloads here. These files are in that folder. There's another folder called Standard Appearance GUI. Both of these do the same thing, and it's really a small, trivial syntax example to see how the functions go together with the TK interface package. So with Python, that's the one we're going to look at. It wasn't the very first one. There were several attempts along the way. GUIs have been around for a little while, but the TK interface package was developed in the late 80s, 88, 89, and it is the one that almost every package for putting together graphical user interfaces since then is roughly modeled off of it. We just talked about objects, so that parent-child relationship. TK is the parent of all the ones that have come since, basically. They followed the model that was put together for that. It was made in the late 80s, and it still kind of looks like it's made in the late 80s. There's another issue there that Python made it officially part of the language, and they're stuck with it. Java did the same thing with a different one. They picked something in the mid-90s and made it officially part of the language, and around 2014 or so, they tried to remove it from the language, and they couldn't remove it because of backward compatibility. They're either stuck with it forever, or they have to abandon backward compatibility at some point. And Python has the same thing with the TK interface package. You will hear it pronounced lots and lots of ways. When we import it into a file of Python, we import TK-INTER, abbreviation of TK interface, and people have come up with lots and lots of ways to pronounce that. You'll hear it written enter, lots of different things. So I just go ahead and pronounce it fully out. I don't use the abbreviation that we type. I'm never quite sure what to say, but I do know what the full name that's an abbreviation for is. So I always just go ahead and say the TK interface package. Different things have come and gone. You will hear different things over people have put different things of what TK stands for, and it was somebody's initials. When he finished putting it together, he did not put a name on it. He turned it into his managers and asked what it was called. He went, so they put his initials there. And over the years, people have come up with lots of different things that it could stand for. And y'all have probably encountered it before. There's a lot of humans out there that if you ask them a question, they'll answer it. And over the years, we've seen a lot of answers, a lot of different things, a lot of different ways to pronounce it. But it wasn't given a name, so it used his initials. Used somebody's initials. Was the start of it. But these two GUIs, one of them is an object-oriented notation, and that's what our book shows. And frankly, I think that's a little bit confusing because was a really, really short chapter covering object-oriented stuff, just barely introducing it. And then when the book jumps into the graphical user interfaces, they do some fairly advanced object-oriented stuff all of a sudden. So it seems to come out of nowhere. And then the other one is written with functions and variables like we've been using the whole semester long. So that's what I was going to do in class. So if you want to put your GUIs together that way instead of what the book does, I am perfectly okay with that because we haven't covered enough object-oriented class notation things to suddenly start working with it entirely. And we're a long ways from where we would get any of the benefits from that. There's actually anti-benefits until we get much, much further along the software development. There's a loss in efficiency and we're not getting any of the advantages. So it's actually anti-beneficial to do the code that way at this level. But either way, what this GUI does, I'll go ahead and run it. Or is this stuff on the background? So it's just the bare minimum stripped down example. So you can see up at the top, there is that file menu or main menu. The only thing there's the file menu and it only has one button in it. We click it and it has this button. The program just says hello world. It's just hello world. Brings out a message to the user. We type a name in the box and then click that button again. It actually uses that name. Then there's a toolbar with a button that says the same thing. So I'll spell out my name this time. And clicking the toolbar does the same thing. It only has one function. It just does hello world. So whatever name is typed into the box here, all of our buttons address that, change that, and then down here in the main content, oh, and notice down there at the bottom, we have that a status telling us what's going on. But the status bar is not really changing. Click the button there, or something else like human, and then if we right click, we get a menu that has functionality for our GUI. There's only one function on this. This is the stripped down syntax example. So I didn't want to clutter it up doing a lot of different things. It only does one thing. But there's lots of different ways to do that one thing. And all of those key components, that conventional appearance, are there. So for the other ones, like a tool ribbon, instead of a main menu and a toolbar, putting that together is a combination of main menu and toolbar. So we just put those two pieces together into a single piece to do that. And the hamburger menu is stacking up our main menu vertically instead of horizontally, as well as adding in functionality so that we can hide and show it when we click the hamburger. So just small differences there, but the general idea hopefully makes sense. It is important to follow those conventional things. The other one does the same thing. Must have clicked that one first time, so I click on modular, and it's the exact same thing. The status bar says it's ready, and when we click a button, It updates the status to say what's going on. We have buttons in the main content, buttons in the toolbar, buttons up in the main menu, and there's really only the one function, but there's lots and lots of ways to ask for that function, to call that one function that it does. I sent this out in an announcement right before class, but let's take a look at these files. I'll open up Spider. There's also another thing in here. Being made in the late 1980s, the reference was on, the documentation was on paper if it ever existed to begin with. But the documentation for the TK interface package is long gone. It was long gone decades ago. And it's officially part of the Python language, has been since the beginning. And actually, the TK interface package, we will find that in most of our languages. It is in a surprisingly large number of languages it's built into a lot of languages. So it's not just a Python thing. That library is available in lots and lots of different programming languages. But the documentation is long gone. So I think around 2011 or so, a teacher at New Mexico University, Python was starting to take off. And I guess he got frustrated with the lack of documentation. So he went through and used the computer, searched through the source code for it and stuff, and used the computer and built some documentation, which is very, very thorough, but it takes some practice getting used to the way he wrote it. But it's the only thorough, complete, full coverage documentation we have for the TK interface package. And at first, it's hard to see how he was notating things, but after you see a couple examples and it starts to make sense, you'll understand where it's very clear and very easy to find the information in. But he just kind of did it in his own style, so it's not the easiest thing to follow either. So let me go over here and open up those files. So I'll look at the module one first, because we haven't looked at very much class notation. We talked about that very briefly the other day. So up at the top, the abbreviation from the TK interface package. You'll hear that pronounced lots and lots of different ways. So you can pronounce it like you want. I just go ahead and say the whole thing out. You'll notice I added a bunch of comments in here. I don't think we've used that much in class. I wrote this example a couple years ago. Switched to doing the import, putting the word import first. If we do it this way, the from our module import asterisk, which means everything, or import just particular things. If we do it this way, we don't have to type in the name of the library it comes from. But since I wrote this a couple years ago, I decided at some point that actually typing the name of the library it comes from is probably good for classroom examples. So I think we've mostly used the import, the one that has import first throughout this semester, but we get the same result. We just don't have to type the name of the library. So we import this library, and then we start setting up the functions of what it's going to do. This one only has one function. It just prints that message. It changes it checks to see if anything's typed into that input box, changes the status bar, and then prints out a hello message. Or if nothing was typed into the box, it goes in the default username to work with. and then prints a message. Nothing fancy there. Then what's called event-driven programming. That's the big thing. Talk about with GUIs. We'll talk about that some here this evening. But a secondary method for when we have an event that is going to be passed in, we need a method that has a parameter to accept that event and get rid of that and call the other method. There's multiple ways to do it. Last couple times I taught this class, I think I just went ahead, instead of making two methods, I just went ahead and put the event parameter and then passed in none on the times that didn't need an event. Here's what that right-click menu looks like, and a right-click menu always looks like that. It's exactly like that. If you copy and paste it from this file I sent out, you can copy and paste it forever, and it will handle every little right-click the menu you want in the PK interface package. The term for that is context menu. You've probably never actually heard the technical name for it, but that right-click menu is called a context menu, and you can just copy and paste this code forever to bring those up. And here's where it starts. So the first thing we do is we create an instance of this object, and then we go some adjust the title and set the size. This is a standard type of string. So when you set your size, you want to do it with the geometry object. That is a standard thing that our code can get from the screen it's running on, from the computer itself. If we ask the computer how big our screen is, it will give us a geometry object, which is a string that has two numbers and an X in between. In this case, 500 by 300, but that's not really a screen size. But that's the format that your computer will tell any software you run what size the screen is. So if we probably want to use that in our code as well, so that we can adjust to a given screen size. Not in this trivial example, though. Here's what a main menu looks like. We create a menu, and then we create our menu, and to that menu we add a command. We'll talk about what lambda means here in a minute. You'll want to do that. The book also uses this command function a lot, parameter. That was something they tried. It was an idea they had when they started putting the PK interface package together back in 1988 or 87, whenever they started. They had that idea, and that idea they gave up on before they even finished this library. Before they even finished the project, they give it up on that idea. So that's actually not a good way to deal with this stuff. There's a better way, and I already mentioned that just about every GUI package we would find is roughly based off of the PK package. So obviously the idea they gave up on halfway through their project, and they even made it halfway into the project before they gave up on the command parameter, is not what shows up in other packages. Binding is much better, which is what's going on down here by on this one. So then another menu, we set the menu, and then we add a command to it. Oh, that's the right click menu. And then we add our main menu. We add that second menu as a cascade. I don't think our book shows that. Binding looks like this. It's always the word .bind. And then we have a string. Inside that string are some angle brackets, and inside the angle brackets is the event we want. So here is button 3, and I'm talking about binding. Scroll way down here. Here's another one. Notice just that dot bind method. And then we have a string with angle brackets inside of it. And inside those angle brackets is what we want the binding to address. A quick little note here. Notice that this is pressing the shift key, and shift key makes H a capital letter. So when you type the binding, if you use shift, make sure you use a capital letter. And if it was just control H, you would want to use a lowercase h there. So the shift key, if you're going to push the shift key, which is just the word shift spelled out, it changes what letter key you're looking at. Or if it's one of the digits, you would want the symbol that you actually get when you push the shift key if they're both involved. There's that word lambda again. We'll talk about that. And after that, it's mostly stuff that what the book has. We have containers. Frames are the standard container, just holds a bunch of other things. So like the toolbar I set up as a frame, a container, and then inside of that is a button, and the rest of that is just to put a picture on that button instead of words. So it loads in a picture, and then subsample divides. So the picture was too big, so to make it 4 times smaller, set the subsample 4, and then that takes the size and divides by 4. If you need to make it bigger, you divide by a fraction. If we divide it by 1/4, dividing by a fraction is multiplied by the reciprocal, so divide subsample by 1/4 would make it 4 times, be the same as multiplying by 4. If we wanted our picture bigger, then we can put a picture on the button instead of words. I wrote this a couple years ago. It looks like I kept using the command one. It's there. It's not going away. It's okay to use it, but binding is a little bit better. Binding always looks like this. Bind. Button 1 is your left click. Button 2 would be clicking the mouse wheel, the middle button, and button 3 is the right click. So even if you have a mouse that only has 2 buttons, if you have a 2-button mouse, the buttons are 1 and 3. 1's the left click, 3's the right click. Those are the ones you need to know to start off with. We get our container for the toolbar and then the button. And then we just keep setting up the stuff before we actually put it all together. The main content, the main section of that window, I can point up here on the picture I drew. The main content area of that standard appearance is a container. And then we put a label and an input box in there. And then a button. So there's the main content, click on that. Set all that stuff up, and then another container, a frame, which is just a holding spot for the rest of our widgets. And the status itself is just a label. We just put a label there and change what words are showing. That's a really easy thing to do logically. We're going to look at GUIs for a while. So this is just first pass at it, previewing it. Then when we go to load things in, the main menu is special. The TK interface package is what's called a native package. And that means that there's not, it's not entirely defined what each widget that we put on our GUI is going to look like. There is some aspects where it will ask the operating system what things will look like. And a menu is the extreme example, because a main menu for a GUI, like we have up here in Spider, is very different very different here than what it would be on a Mac. I guess I could have logged on to my Mac. Right? In a Mac, we get the menu is completely separate from the GUI sitting up top, and certain elements are pulled out of other menus, like preferences is usually under edit on a Windows machine, but on a Mac, it's over there under the application button. So our menu is very, very different. So for the main menu, we have to let the operating system set that up. So that one, the main menu, we configure the menu, and all we do there is just GUI the name of the window we're making. Then we say .config, and what menu do we want to put in there. Then the rest of our stuff, we have 3 options, but don't use one of them. So we have options to either pick things in or lay them out as a grid. And there's also the option for place. Place worked really, really well back in the days of cathode ray tubes, when all of our screens were exactly the same, and the size of a pixel was entirely dictated by the physical size of the imprint left behind when an electron gets thrown past a cathode, or so that it bends to a particular spot on the screen. There's some physical restrictions, so our pixel size was always exactly the same. There were we could have different screen sizes, but we had physical restrictions on the size of the pixel. It couldn't be bigger or smaller than that, because that's just the size that's the mark we get when an electron hits glass. Physical properties of the universe. And moving past an electron with the voltages that it would run at, there's only so many angles moving an electron past a cathode, there's only so many angles we can bend it to, so we were also restricted on our aspect ratio. We could have different screen sizes, but the ratio of height to width was the same. Back in those days, the option for place worked really, really well. On modern machines, place doesn't go so well. And you end up with a lot of trial and error, and it will do things that you probably didn't expect. For example, on the Zoom call, you're watching this on a modern screen. Do you have sips or dips making up your screen? Is it screen independent pixelation, or is it density independent pixelation? You probably don't even know that about your own computer, right? I certainly can't answer that question. I have no idea what my HP is here. I know what my Chromebook is, because that one's normalized. That one's standard. Chromebooks don't come with it. Chromebooks get very, very expensive before we get to the options. But we have different types of pixels and things, so place doesn't work as well as it used to in the days of cathode ray tubes. So the other two, pack and grid, still work great. So pack just starts loading things in. We have our big GUI that we put together, and we say pack, and if we don't give it any other parameters, or we don't send any arguments to fill parameters, it's just going to put that at the top center. And then when we say pack something else, it's going to put it right underneath it. Pack something else, it'll put it right underneath that. Right underneath that. So pack just starts at the top, and we keep packing things right underneath it as we go down. Grid is like the name sounds. We set up rows and columns. The top left is row 0, column 0. And as we increase our column number going to the right, and we increase our row number going down. That should probably not come as any surprise whatsoever. And there is a restriction on how we mix and match. So for the most part, you're going to want to use pack and grid. And this is what I usually do here. We can mix and match them to an extent. Actually, I should say that we can't mix and match them in the same container. So once if we pack the first item in, if the first widget that we put in our GUI, we use pack, then every widget we use afterwards has to be. But if one of those widgets that we pack in is a frame, a container itself, then we can go into that container, that frame, and use grid. So, but if once we load the very first widget into that container with a grid, we can't pack anything there. We have to use grid throughout that for that entire frame. Hopefully that makes sense. So we set up our GUI. And if we load the first widget in by packing it, we can only pack in the only option we have for the next widget is to pack it in. Or if we load the first one in with grid, the only option we have for the second one is to load it in with a grid. But inside either one of those, once we get into that next layer container nested in there, we're free we can start over. So the mix and match is, inside of any particular level of container, we have to stick with it. Same thing for placement. Once we use place, we have to stick with place. We can't switch back and forth. So what I usually do is those overall containers, the toolbar, the main content, or the toolbar is going to hold a bunch of buttons. The main content holds most of our stuff. So like looking at Spider here, the toolbar holds a bunch of buttons, and down below that is the main content that, well, right now it's holding a text editor, file explorer, and an IPython console. And then down at the bottom, we have a container for the status bar, telling us the status of what's going on with the program and all that. So those main containers, I will pack in, and then those just go in top to bottom. And then inside of each container, like the buttons for the toolbar, I'll set up a grid. So then there's a grid for how the buttons in the toolbar are laid out. And the packing it keeps that toolbar up there at the top, nice and organized. And then the grid keeps everything organized inside of the toolbar. Same thing for main content. It gets packed in, but then the stuff inside of main content, I use a grid for. I guess on the status bar, I packed the status bar, and it looks like I just used pack here to put it in there. And then we have some parameters. We can say which side it's on, and fill, have expand, where I don't have expand on there. Fill goes horizontally and expand goes vertically. Sometimes we need both of them. And it's very inconsistent because fill, you can see it's a string. Fill both, start in the center and fill in both the X and the Y direction. And expand is true and false. So to stretch things vertically, we give a true or false parameter. Very inconsistent. So something to practice around with, then check the documentation on, things like that. White space is also critical. We're not really getting into design components, but that's another thing textbooks do. Textbooks never seem to mention white space in the GUI. When they put a GUI together, things are just crammed in there in the smallest possible space they can take up. And then eventually, we call this method the main loop method. And then main loop just runs forever until we close the program. So that's the basic idea of what we see with the GUI. If I run that, this is for the standard appearance. I put this together for y'all to reference and kind of see what's going on there. As always when programming, there's some wiggle room. So use this as a reference. I put lots and lots of comments in it so you can look at it and see how these pieces go together so that you can start right from the beginning, start making your GUIs look correct. Like what a GUI is supposed to look like. This is the old style, but it would get you a start. And then if you like the hamburger style, once you know how to put a GUI together, it's nothing to go line the main menu up vertically on the side and either show or hide that with a toggle button. That part's really straightforward. And the other one is the same thing, but with class notation. So import the same library, but this time it's created as a class. And if it doesn't have any child classes, if nothing is inheriting from this, it's anti-advantageous to make our GUIs this way. Unless you just really, really like the notation. But if we're not inheriting, we're only making one thing, we're adding a bunch of extra words in order to make that one thing. And we're being wasteful with our CPU and RAM because object programming is less efficient it's less efficient to do it this way. Python's only object oriented, so actually when we do it this way, it's not functional or modular like I wrote there. It is technically still object oriented, but it's a static object. And static means there's one and only one copy. So we don't end up with a whole bunch of duplicates, potentially bogging down our CPU and sitting there burning through a bunch of spots in RAM when they're never going to be used because they're just a redundant copy of the thing we're looking at. So unless something is inheriting from it, there's no advantage to doing it this way. Unless you just really like the notation. I guess what would be an advantage is the most popular programming languages in the world are all object-oriented programming, and Python's the only one that gives us that alternative. So everywhere else, we would have to use classifications because that's the only way we can write in that language. So it's consistent with other things. You'll notice here, we call that TK object as a particular parameter of this one. We set up a parameter in our class, a data field, and then assign that to that TK object. And then that's what we use to set the title and the geometry and our little picture up in the corner. Then we do the same thing. Our menu's the same. The biggest difference is we have to type that word self all over the place. Like we were looking at Monday for class notation, we have to leave a spot for the Python interpreter to send in the parameter of the thing it's actually of the object itself. Kind of a mouthful, but we have to put that keyword self all over the place. So really, this gives us an extra word that we have to type with every single thing we do. Order does not matter with class notation. The class gets compiled, so we don't have to worry about the order of our functions. Doing it the other way, we had to be very careful to define our functions way up here at the top, so that whenever we got around to making our buttons, the function had already been defined before the button click that calls it. And with the class, we can put it at the bottom. So I guess some people might see that as an advantage. We don't have to worry about the order we do things in. Context menu is again going to be a copy and paste thing. It's at the bottom here. The toolbar is still a frame. We load in an image and then create a button with that picture instead of some words on it. And then it just calls a function with this lambda thing. Main content, you'll see it all does the same thing. So really it comes down to personal preference. Would you rather do it with the static object, which we've been treating as functional programming throughout, or procedural programming for the first, 4 weeks of the semester? And then in week 5, finally mentioned that, oh yeah, it's not really procedural, it's a static object. It is still object-oriented programming, but whichever style you prefer to write in, we can do the same thing. This is what a binding looks like, and notice some things go with the root, which was that PK object, that initial thing we created, and others go with the self, the class we're defining. Then we put all the methods down here, sort of the same thing. That requirement, the self parameter has to go first, and otherwise it does exactly the same thing as the first one. Oh, and then main loop, I just called at the bottom of the constructor. That special init method that we were talking about the other day. Because all of this stuff happens in the init method. And then we have a couple other separate methods that the buttons call. So that's there for your reference. I sent it out, that standard appearance. Also for reference, this is what's generally considered the go-to reference for the TK interface package. A teacher at this college in New Mexico put this together 2011 or so, when there wasn't any good documentation for him to show this in a class, when Python first started to really grow in popularity. But he has a unique way of covering things. So canvas is how we draw on things. Check button, I'll go to that. Check button is something we're going to want. We want our toggle control. Is our box checked or unchecked? Is on or off? True, false, yes or no? Our Boolean states. We either check the box or we don't check the box. So it always looks like this. It has a little description on it. It talks about what to do. It shows how to create it. And he always imported the module as TK. So TK.checkButton. And the first parameter that all of our things need, we're going to do an example here in a moment, is what is the parent of it? There's lots of parent-child relationships. We start with the main window itself, and then every time we put something in it, if it's a button, an entry box to type code into, a great big text editor to type entire text files, canvas widget to draw on or display images or play videos. Any of those, the very first thing is the parent, and then the options that it has. And then there's a table of what those options are. So this table has all of the parameters that are special for a check button. And somewhere up near the beginning of this big long PDF, there's a table like this that has all of the common parameters, the ones that every single one of our widgets will have. And then the table here has what's unique for a checkbox. Actually, some of these are common. I might have got duplicated. What's the cursor do when you hover your mouse over the checkbox? What font is it written in? What's the foreground color versus what's the background color? How tall is it? The indicator on is what that is. So check. Is the check mark showing? The indicator on in our Boolean's true. some padding. A relief is the little border around things, slick image. We're gonna talk about these for a couple days. But it's a little hard to follow the style at first. So this is back to that thing I've mentioned a couple times. Treat this one like official documentation. It's pretty well standardly accepted as the best documentation after the TK interface package. So look here first, and it's probably going to be a little confusing when you first few things you look at. You look up a check button like what's shown on the screen here and be like, okay, this doesn't make any sense. I don't see what to do with, understand what to do with this. And you go find a nice simple YouTube tutorial to follow. Remember to come back here, and then after you see that nice simple case, you'll be like, oh, that's what he's talking about. Because the tutorial will only introduce it. And this has the full picture. This has everything we can do with the checkbox. After the table, there's the methods that we have built into the checkbox. So this is the full user manual. So make sure you're using the tutorials, which are nice and easy to follow, but only that very beginning basic step. Use the tutorials to learn to read the user manual, and then you can figure out what you need when you need it. I guess let's go ahead and do a real quick thing on the pass, a real quick passport and some stuff. So I'm going to import the TK interface package as TK, because the abbreviation TK seems like it'll be a whole lot easier to type over and over and over again. So the very first thing we want to do is create our window that we're going on. Call it that. That's a good name for it. We want to make the window itself. So window is going to be assigned this special object from that library, tk.tk with parentheses. And the object has a capital T and a lowercase k, and then the parentheses. Next up, I'm going to scroll down here to the guard statement. I'm going to add some white space in because I don't like working at the bottom of the screen. And in the guard, so our starting point, right? Well, this is where we actually start our code. This is essentially a main method. There is an official thing to do that in Python. So I'm not sure why our textbook author kept choosing to actually write a main method, but really the guard statement is our main method. That's where we start at. So when we get down here to the starting point, we're going to ask for that object we just created. Well, we created it way up at the top. We're getting ready to do a whole bunch of stuff there. We haven't done anything yet. So the object we just created, and then dot main loop as a method. And then go save this somewhere. GUI example 1. .py. Now when I run this, we get rid of that. And those two lines get us that much right there. Pops up a window, has a default little feather icon, and then our minimize and maximize and close buttons coming from the operating system. So if you're in this exact same code on a Mac, you will get something that looks different. Why don't I do that? Just to show it instead of saying it. I'm not doing anything on that computer. I can close it instead of just setting up setting another computer on the keyboard. So let me run that again. So those two lines gets us a basic Windows looking window. So if I sign on from my Mac here, there we go. Sorry, I had to remain quiet for a second because my Mac refuses to sign into Zoom without turning the microphone on. It's like, no, you can't choose the option to turn the mic off. It's a Zoom call, you need that. But let's see if I share the screen here. Well, I thought I had Spider, but I don't see Spider on here, so I'll just use idle. And I'll write those same two lines, or I guess it's actually 3 lines because we need to import that, don't we? Import TK enter as TK. Then window is tk.tk. And somewhere down here, if name is equal to main, which that just means if this is the file we hit the run button on, then do window.mainloop. So if I save that, and then hit run, notice this time we got those same lines of code gave us what is clearly a Mac window. That's what's meant by native package. So it will look right whatever system you're running on. You don't have to make extra changes. And I'll just log off with it here and go back to the PC. But the exact same lines of code gave us something completely different on the different system. It gives us an appropriate window for whatever system we're on. And then to load things into it, there's that example, but our basic format is we need some sort of reference, so basically a variable. We need to create a variable to hold one of our widgets. That's the term we use. So something we're often going to need is a button. Let's just do a hello world. So we have a button, and there's different ways to notate things. So what I like to use Hungarian notation. I think that's shown up somewhere along the way. It's on that list of that weekly list of notation to use. Hungarian notation uses a small prefix, 1 to 4 letters to say what type of thing it is, and then a useful name. And then having multiple conventions like that allow us to mix and match our notation so that we can use the same keywords on things that go together. So, like an input box, right, where we're going to get the user's name, We could call it TXT username to indicate it's an input box to type text into. And we use Hungarian notation for that, the little prefix at the beginning. And then after the user types something in and clicks a button to submit that, we can call that BTN username. So we're still have that same useful word. It's the button that refers to inputting the username. And that prefix gives us different variable names. And then when we load that into our code for normal backend programming, the word username is still available. I usually do that in camel case on the background. So Hungarian notation for anything that shows on the GUI, and camel case or Pascal case for the stuff in the background. And mixing the notations like that gives us a very nice clean way to keep using meaningful names, the most meaningful name for the whatever value it represents. And then we don't have to come up with a different useful name every time. But they are different because we notate them different, capitalize them different. This one I'm just going to call clicker because there's not much going on there. So Hungarian notation, BTN to say it's a button, and I'll just call it clicker because I can't think of anything else to call it. And that'll be a TK.button. And all of our widgets are spelled with a capital, start with a capital letter. They're spelled in Pascal case. So you'll see on the predictive text there are a whole bunch of things popped up. There's a bunch of things we need. The very first one is, what is the parent? What do we want to put this button into? And since this is our very first example, and we're only going to go for about 10 more minutes. I'm expecting it to take about 5 minutes to put this together, and then that's going to be it for tonight. That's why we're not taking a break at the normal time. We're gonna be ending before 7:30. Just to let y'all know why we're not taking a break at the normal time, because there would only be a couple of minutes left after a break. The break would be longer than we have left for the night in total. So the first thing is, what are we putting this button in? And well, right now we only have one place to put it. We want to put it in our window. And afterwards, there's our next, all the other parameters are optional. We'll probably want some sort of message on here. We haven't loaded an image or anything. We don't have an image to load into it. We'll see that next week. But for text, is it label or text? I think it's text. It might be label. I'll never put text on buttons. I put pictures. So it's not fresh on my mind. And then that's going to be assigned some words that we want to put there. In our case, let's just throw some words on the label. Button label output is a tk.label, which is just a thing to hold some text. And once again, what is the parent? What are we putting it in? So our label, we want to put that on our window, our main GUI overall. And right now, we don't have any text to put on there. When we click the button, we'll put the word hello world. We'll put the words hello world there. Now to put that on the screen, that's where we use the pack or the grid. Place worked really, really well back in the days of cathode ray tubes. But like I asked a moment ago, without looking it up, do you know if the screen you're looking at right now has sips or dips? Are things measured with screen independent pixels or density independent pixels? Kind of hard to know, right? Without looking that up. So place doesn't work as well as it did back in the days of cathode ray tubes. So I'm going to stick with pack and grid for ours. are class examples, but there is a third one that exists. So now to put those in there, we'll just start with the basic pack. So we'll say button clicker dot pack. And if we don't give it any parameters, it puts it in the center at the top. Oh, I spelled that wrong. It's a variable name, capitalization matters. And then right after that, I'll put the label output and pack that in. Give that a run. See the size changed a little. It squeezed down from that default version we had earlier, and now there's not even enough room for our minimize button. We have close and maximize, but it only took up that most basic amount. So something else we can do is we can do window.geometry and then assign that a value, which I think goes in this way. No, it's a variable. Equals a string of 700 wide by 400 tall, roughly. I was thinking that went in with parentheses, but that is a standard type of string. I'm going to look at the earlier example real quick because that just looks wrong when I look at it. So okay, yeah, this has geometry going in parentheses. Spider's predictive text is telling me that's a variable. But the example that I just showed you all shows it as a method. I guess they maybe gave a variable and a method the same name. They didn't write the cleanest code when they made this module. This is a standard type of string that we get from our devices. Any device we're running code on can provide us with a string that looks like that. Digits, then an X, and then other digits for width by height. Now there's a nice big thing. So you can see our button's centered there in the middle and a nice big starting size. So geometry is the best way to do that because we can ask any computer for a geometry number and get the screen size from the computer. Now we need to change that text. So to do that, we need a function. And we want the function to exist up here. We need it to exist before we call it. So I'm going to define a function. I'll just call the function say hi. And I'm going to set that function to bring in an event. So programming uses event-driven programming. We'll talk about event-driven programming more explicitly next week. But basically, an event is anything that can happen. I remember at the beginning of the semester, I defined a computer as a machine that can detect, identify, and react to a change of state. An event is any state that can change. Pushing keys on the keyboard, clicking buttons, moving the mouse, hovering the mouse over something, key audio words, light sensors, timer events, anything that can happen, basically, an event. So we sit around and just wait for events to happen. And when a particular event happens, we want to run this method. And what we want to do is change the text on this label. And this will be an important way to state this. Every widget in the DK interface package is a child, a subclass of, or it inherits from, with object-oriented programming. The parent of all of them is a dictionary. We saw a dictionary. We introduced it. We didn't get see the full picture here, but we introduced it as, you can think of it as a list that instead of indexing it with numbers, we index it with strings. That's a good start into what dictionaries are. So every single widget is a subclass of a dictionary. So that's how we access all of our parameters. So to access this text parameter and make a message appear, we can just treat it as a dictionary. So up here, we can say, when this event we're waiting for happens and this method runs, then we're going to take label output and index the text property from it and assign that the words hello world. Our standard configuration check. Right? If we can print the words hello world on the screen, we can do anything, because that means everything's configured correctly. And if we can't print them in there, then we need to make sure and go to our configurations before we do a bunch of complicated things, because we can't even get words to show up on the screen. So our standard check to start with, we just treat our widget like a dictionary to access any of the parameters that were probably, most of the reference materials and tutorials are going to show those things in the constructor here, but we just access them like it was a dictionary. And now to call that, I mentioned this earlier, there's a parameter command that is in some things, but they gave up on that. They gave up on that idea before they even finished the first draft of the TK interface package libraries. So a better way to do it is with binding. So what we want to do is we want to bind an event to that button. So I'm going to ask for the button, so BDN clicker, and dot bind, and there's this method dot bind. That first thing we need to do is say what event we're binding it to. And events always look exactly the same. There are strings, so we have quotation marks, and then we have angle brackets inside those quotation marks. And inside of those angle brackets, we type the event we're listening for. So for us, we are listening for a button click, a click on that button. So a mouse click is going to be button -1 is the left click. And button 3 is a right click. And there's lots and lots of them. We're going to see more of this stuff. And when that happens, we want to call the method say hi. We'll say, okay, run the say hi method. And here's where we actually hit a problem. Typing the word say hi there, we've talked about this before, without parentheses, when we just have the word, at this point, a method is just a variable holding a bunch of instructions. And when we put those parentheses on it, it will run. But there's a problem, because the computer is going to start going through this code and reading going through this text file, translating these instructions into something the machine can run. And if it immediately gets down here and sees parentheses, it's going to run that method immediately. But we don't want it to run when the computer knows that function exists, or that method exists. We don't want it to run until we actually click on it. So we have to use what's called a lambda event. And this is not a Python thing. Lambda events were created with Lisp in 1958. And they are in every single one of our languages. Java was the last language Java was the last holdout not using lambda events. The lambda functions. But basically what a lambda function does, it does a lot of stuff. What we need the lambda function to do is wait, because we have to put those parentheses there. Right? our method takes in a parameter. We can't send that parameter later unless we type it now. So we have to have parentheses there, but we don't want this function to run until we click on the button. So to do that, we put in this keyword lambda and then a colon. I think I have to do this. So I go here or here. I gotta look at the syntax example again, because I was just doing this in Java a couple nights ago and I forgot the syntax for Python. I can't remember if I typed my reference value before or after the colon. I'm pretty sure I put lambda events in here. No, I didn't, did I? Oh, there it is. Before the colon. Sorry. Languages run together as we learn more and more of them. So lambda functions, one of the things they will do is wait to run a function. So I'm gonna put lambda and then just an E. So lambda is waiting on something. And since it's in an event binding here, the computer's gonna know that it's waiting on that event that was just found. We're waiting on that event, so when that event happens, it will pass all the information about it into this little variable we call E, and then we can use that to send that up to our function, which we're not doing anything with it, but that keyword is necessary. So the keyword lambda, and then some sort of variable name for the thing you're waiting on, probably an event for everything we do in this class. A click event, a keyboard event, you might want to use different letters to be more specific, but an E would probably work because they are all going to be events. And then we can type our parentheses here without actually having to, and this function won't run as soon as the Python interpreter knows about it. It'll wait until we get that button clicked to run. So to start off with, think about lambda is the instruction for the computer to wait. It's not a Python thing. Lambda functions were created in Lisp in 1958. There's not a programming language we would even consider using today that does not have a lambda function in it. So bindings are much better way to do it. That's what we have across the board with GUI packages. And all of our programming languages have lambdas, so you want to use those two instead of that command parameter. We can always bind stuff. We could bind a button click to that label, and then that label gets clicked on like a button. Okay, I meant to end 2 minutes ago. There we go. So when we click our button, we get the hello world. A very quick pass at a first example. I have to actually close it to start over because it doesn't do anything. But notice, even though the parentheses were typed there, it's been running for a second, so by now the Python interpreter certainly knows that there was a function call with parentheses in the code that we passed to it. But that function hasn't actually ran yet. It was placed on the stack, but it hasn't been popped off the stack to actually run until the event happens. And when that happens, we get a nice little message. Oh, Joseph just showed up in the waiting room. He told me he was going to be late, and that was the last thing I had to say. Does anybody have any questions about that? And I'll go ahead and let Joseph in and let him know that was it for today. Hey, Joseph. We were actually just finishing up. Probably could have said that earlier when you sent that message. I knew it was going to end up, I was thinking around 7:20, which would have been before you logged on there. A short night, and right before it came to let me know you were in the waiting room, I asked if anybody had any questions to finish up this evening.
Oh, okay.
So, everything's recorded like normal. If you have any questions, check the recording, let me know. Otherwise, have a great holiday, okay?
Oh, okay. So okay.
Yeah, yeah, we were just wrapping up for the day. Some stuff about GUIs. And I did do a cross-platform example to show that the same code in a Windows machine and a Mac machine runs an appropriate looking GUI. So check out the video. That way, usually Mac users are stuck learning about packages that make things that look like Windows GUIs to run on their Mac. But this one will actually look like a Mac GUI when you run it. But there's an example about that when you check that. Otherwise, I assume the silence from everybody else means no questions. So that was a long time for a break. I was thinking it was only going to be about 5 minutes or so longer than we would normally be getting to our break. Otherwise, campus is closed for the holiday week. I am pretty sure I am the very last person on campus here, except for the security guard and maybe the janitor. Patient waiting on me to leave so they can go start their holiday. Otherwise, you all have a great Thanksgiving. If you have any questions, let me know. I don't really have any plans over the weekend, so I'm always happy to help. Let me know if you're trying to catch up on work and need some help or anything. Otherwise, I will see you all on Monday, and we're just gonna kind of look at GUIs in more detail then. Y'all have a good one.
All right, you too. You have a good
All
Thanksgiving.
right, thank you.